That's because the answer was a fraction, 5/2. But you can still solve this question by changing the bases and solving it that way. The last section of notes today is titled Solving Log Equations. First problem is log base 9 x equals 2. Same steps as before. Anytime you have a log equation, you can switch it into exponential form and then solve. For example, the 9 would be the base, 2 would be the exponent, and it would be equal to x. 9 squared is 81, so x would equal 81. Second question, log base 10, parentheses, x squared plus 1 equals 1. Same thing as before, we still have our 3 letters here, A, B, and C. We can switch them around to exponential form, which would be 10 to the first power equals the entire expression, x squared plus 1. 10 to the first power would just be 10, so we can ignore the 1. Solving for x, we can subtract the 1, and taking the square root would be 3, and we'll also have -3 as an answer for log equations. Just like in exponential equations, the log number has to be positive. If we plug a 3 or -3 in here, when it's squared, it'll be changed to positive, so they'd be okay. But for log equations, the number you're taking the log of has to be positive, it cannot be negative. We have 4 properties of logarithms. The first property, we have log m times n with a base b. If we multiply inside logarithms, we can split it up to 2 logs, log m plus log n, and both logs will have the same original base of b. Second property is dividing. If you're dividing inside logarithms, m divided by n, we can split it up to 2 logs. We'll have log m minus log n, and again, both with the same original base, base b. The third property involves exponents. If you have an exponent inside the logarithm, we can actually bring that exponent to the outside, and we'll be multiplying p times log m with the original base of b. And last property, if you have log of b, base b, so you have the same number inside the log, that's the same number as the base, those will cancel, and you'll have just 1 without any logs. Title of the first section today is Expanding Logarithms. In this section, we'll use the properties of logarithms to expand the logs. First question is log 3x base 4. This logarithm has a multiplication inside, 3 times x Looking back at the properties of logarithms, multiplication, we can change to 2 logs. We'll have log with the base 4, 3. And instead of times x, we'll add to that a second log with the same base with x on the inside. So log 3x base 4 is equal to log 3 base 4 plus log x base 4. Second question is log x divided by 2 with a base of 6. Again, dividing inside logarithms. If you're looking back at the properties, we'll change this to a subtraction question. Log with the numerator x, base 6, and we'll subtract a log of the denominator, which will be log 2, the same base 6. And last question for the section, log x squared with the base 10. If we have exponents, again this exponent we can move to the outside, be multiplying by 2 times the log of x base 10. Title of the next section is Approximate Values of Logarithms. In this section we'll use given values for some logarithms and approximate the values of other logarithms. First question, if log 2 base 5 is approximately 0.4307 and a second log, log 3 base 5, is approximately 0.6826, we'll find the value of logarithm 4/3 base 5. These logs are approximated. If you use a calculator to actually find the decimal will continue on. These decimals are approximated or rounded off to 4 decimal places. Solving the first question, log 5 of 4/3 base 5. What we want to do is change this into logs using log 2 and log 3, which will both have log 5. First we can rewrite log 5, and instead of 4/3, we can actually take the log of the first number, and since we're dividing, subtract the log of the second number. So we'll have log 4 base 5 and minus log base 5 of 3. The second log, we have the decimal for, log 3 base 5, but the first log, we have log 4, which is not given in the question. What we can do to solve though is log 4. If you think of 4 as 2 times 2, we're given the log of 2, so if we change this to 2 times 2, we'll be able to use the decimal given. So rewriting this expression again, if we have log 2 times 2, the multiplication property again, we can split up into 2 logs. We'll have log of the first 2, base 5, and adding to that a second log of 2, base 5. And the last log will stay the same, minus log 3, base 5. So rewriting 4/3, we can expand this and write this as 3 logarithms. Each of these were given a decimal for at the beginning of the question. Log 2 base 5 is approximately 0.4307. And the second log is the same value, 0.4307. And we'll be subtracting log 3 base 5, which again is given in the original question as 0.6826. Combine these decimals, adding and then subtracting, we'll be left with our final answer, of 0.1788. So by expanding logarithms and using given information, we can estimate that log 4 over 3 base 5 is approximately 0.1788. Second question, and last question for the section. Again, we'll approximate the value of the log. This time we'll have log 50 base 5. To approximate again, we need to change 50 into the given numbers that we had before. Using the properties, we can change 50 into several numbers. For example, if we write out 50 as 5 times 10, we'll have log 5 base 5 and log 10 base 5. The 10 we can also write out as 5 times 2. So 50 will be the same as 5 times 5 times 2. Since this is all multiplication, we can change this using the properties to the addition of 3 logs. We'll have log 5 base 5 plus the second number being multiplied, which would be log 5 base 5, and plus the last log, which would be log 2 base 5. Looking back at the given information, log 2 base 5 is given as a decimal. Log 5 base 5 and log 5 base 5 are not given. But looking back at the properties that we wrote at the beginning of the section, if you have the same number and the same base, this is equal to 1. So log 5 base 5 is equal to 1, and the second log is the same. Log 5 base 5 is equal to 1. The third log, again, the original decimal for log 2 base 5 was approximately 0.4307. Adding together 1 plus a decimal, our final answer would be 2.4307. So approximating log 50 base 5 with the given information is approximately 2.4307. Title of the last section today is Solving Equations with Logarithms. In this section, we'll solve equations that have logarithms inside the equations. First question we'll solve is log 5 base 3 plus log x base 3 equals log 10 base 3. To solve questions that contain logarithms or multiple logarithms, using the properties, we can actually combine these into one logarithm. If we have log 5 base 3 plus log x base 3, using the addition property, instead of adding 2 logs, we can combine these together to make 1 log, which will have the same base 3. But instead of 5 plus x, we'll change the addition to multiplication, so it'll be 5 times x, or 5x. Equals a single log on the right hand side, log 10 base 3. Solving logarithms, if you have a single log on each side that has the same base, we can cancel out or ignore those. Since the logs are equal and the bases are equal, if the numbers or terms inside the logs are equal, then the equation would be equal. So we'll be left with 5x equals 10. Solving from here, dividing by 5, we'll have the answer of x equals 2. Second question, and last question for the section. 2 times log 10, or base 10, 6. So 2 times log 6 base 10 minus 1/3 log 27 base 10 equals log x base 10. Again, solving questions with multiple logarithms, we want to combine all logs together, so we have a single log on each side, which will have the same base of 10. Looking at the first logarithm, we have 2 times a log 6 base 10. Instead of multiplying by 2, we can use the properties of logarithms, and the 2 we can bring inside as a exponent. So rewriting, we'll have log 6 to the second power base 10. Multiplication on the outside we can bring inside for an exponent. And then minus, same thing with the second log. For multiplying by 1/3, we can bring this 1/3 on the inside. The log would stay the same, the base would stay the same, but we'll have 27 to the exponent of 1/3 equals the same log x base 10. Simplifying further, the log and the base would stay the same. 6 to the second power we can rewrite as 36 minus the second log and base would stay the same. 27 to the 1/3 power. If you remember fractional exponents from previous sections, this is basically taking a radical. The 27 would stay on the inside. The numerator 1 would be the exponent, 27 to the first power, and the 3 would be the root number. So 27 to the 1/3 power is the same as a cube root of 27, or a number times itself 3 times its 27, and that number would be 3. So 27 to the 1/3 power is the same as 3. Equals log x base 10. Simplifying once more, now we have a single log with no numbers outside. The subtraction we can change into a single log. 36 divided by 3. And the base 10 would stay the same. Equals the same log 10 base x. After simplifying and combining logs, we're left with a single log on both sides, the same bases. So again, we can cross those off or ignore those since those are equal, and the numbers or terms inside should be equal also. 36 divided by 3 would equal x, or simplifying, we'll have 12 equals x, or x equals 12. Next section of notes today is titled Change of Base. The formula for this section is log n base a equals log n base b divided by log a base b. any log with a number or a term and a base, you can split that into a fraction using any base you want. Normally you'll use base 10, the standard base, and the n goes on top of the fraction. The base a goes on bottom of the fraction. First problem for the section is log 2, 13. And we're going to change this into the standard base using the base formula for 10. To do this, you'll have a fraction. We'll take log 13. And you can write any base you want, but again, base 10 will be the standard base we'll use. And the bottom part of the fraction will be log our original base 2, and our new base will be 10. When you write this as your final answer, you can leave off the 10 and just have log 13 divided by log 2. If there's no number written as the base, it's assumed to be a 10. If you wanted to, you could also use a calculator to figure out log 13 divided by log 2, and that would come out to 3.7004. Last question for the section is log square root of 6, base 5. And again, we'll change this using our change of base formula. Log square root 6, I'll leave off the 10 this time, and log 5 would be the denominator. To simplify this, we can actually simplify the square root. For example, the square root of 6 is also 6 to the 1/2 power. The 1 comes from 6 to the first power, and the 2 comes from the square root. Divided by log 5 would stay the same. Using properties of exponents, properties of logs with exponents, if you have an exponent 1/2, this 1/2 can come out front and becomes a coefficient of 1/2, which would be 1/2 log 6 divided by log 5. Having a fraction inside a fraction, we can rewrite this as log 6 divided by, instead of 1/2, we can put the 2 in the denominator and have 2 log 5 for our final answer. And again, if you wanted to, you can use a calculator to find log 6, find log 5, multiply by 2, and divide those, and that would come out to 0.5566. Next title of notes is solving equations using logs. First equation will be 5 to the x power equals 52. At first, you can try and solve this by plugging numbers in for x. 5 squared would be 25. 5 to the third power would be 125. So there is no whole number that makes the solution correct. So to actually solve it, we'll solve using logs. For example, this is an exponential form. We can change this question into log form. The base 5 would stay the same, and the x and the 52 would switch sides. 52 would be part of the log, and x would come after the equal sign. For standard notation, all answers should have a log of base 10, so what we can use is the change of base to rewrite this as log 52, divided by log 5. Using a calculator, if you did log 52 divided by log 5, that would be 2.4550. Last question for this section is 8.2 to the exponent of n minus 3 equals 42.5. Again, to solve this, if you have an exponential equation, a variable in the exponent, you can switch that to log form to find out the variable. 8.2 is the base, it will stay the base. And again, n minus 3 and 42.5 will switch sides of the equations. 42.5 will become part of the logarithm, and n minus 3 would be on the other side. Using change of base again, we can rewrite this as 2 logs. This would be log 42.5 divided by log 8.2 equals n minus 3. Again, solving for n, last step, add 3 to both sides. And your final answer would be log 42.5 over log 8.2 plus 3 after the fraction. And again, if you wanted to in a calculator, you can figure out both logs, add 3 to it, and the decimal answer would be 4.7820. Last section notes today is titled More Log Questions. Question for this section is 8 to the exponent of 2n is greater than 52 to the exponent of 4n plus 3. Before, when we had a question like this, we try and make the same base on both sides. We can change 8 to the exponent of 2 to the third power, but 52 cannot be simplified into a base. So if you cannot make the bases the same, what we're going to do is write log on each side. We'll have log 8 to the exponent of 2n is greater than log of the second side, which will be log 52 to the 4n plus 3. By doing logs on each side, that still makes the equation equal, but it allows us to have these exponents with properties of log equations come out in front of the logs. For example, 2n would be the coefficient in front of log 8 is greater than 4n plus 3 would be the coefficient in front of log 52. Now the variables are no longer as an exponent, and working through this we can isolate n to solve for n. What we want to do first is distribute 4n plus 3 times this log. So 2n log 8 would stay the same. Is greater than 4n times log 52. And plus 3 times log 52. Keep in mind while you're solving inequalities or equations with logs, any number with a log after it just represents some decimal. Again, we want to solve for n. Right now we have n on 2 sides of the equations. What we can do is subtract that 4n over, and we'll subtract the entire term 4n log 52 from both sides.